Hello and welcome to Nikolay's genetics lessons, and in this video I'm going to talk about how to calculate inbreeding coefficient. And here's the problem: what is the inbreeding coefficient of the child as a result of the mate of the double first cousins? It sounds confusing, but actually this is a simple life situation. Imagine that here we have one family. He is a male, he is a female, they have two children, and they have two daughters. Now we have another family, genetically unrelated. This family also has two children, but their children are two males. So imagine now that one of the males, say older brother, would meet one of these girls, and they would make a family and would have a male child. And also imagine that this male, say younger brother, would also date younger sister of the wife of his brother, and they would have a girl. Now imagine that these children grow up and marry, so we put double line here, which means consanguineous mating between two close relatives. And now we have to find how inbred the child would be. So inbreeding coefficient. It is probably not very convenient to use this pedigree in order to explain how we are going to calculate inbreeding coefficient. So let me use another line diagram which would be more convenient to use. But we still would need this picture as a reference so you would understand better. Imagine now that this male represent this male here and his wife, and as you remember they have two children, that is girls, and 50% of the genes this female got from her father, and another 50% from her mother, and another child also got 50% of her genes from father side and 50% of the genes from the mother side. And also we have another couple here, and this couple has two sons. Once again, each son got 50% of his genes from father side, 50% from the mother side. So we would see a picture like this. And now we have a mate here that resulted in female, and here is another mate that resulted in male. So this is exactly what we see here. And now this female and this male also mate, and we want to find what is the inbreeding of this child would be, what is the inbreeding coefficient. So in order to demonstrate how we calculate inbreeding, let's imagine that we have to find probability just for one locus to be homozygous and to be homozygous by descent. In order to demonstrate what I am talking about, imagine that genotype of this male would be A1, A2. For the, say, gene A would be heterozygous. This female also would be heterozygous and would be A3, A4. This male would be heterozygous, A5 and A6. And this female would be A7 and A8. So now we have to find probability that this child would be homozygous for any of these 8 alleles. So let's find, for example, what is the probability for this child to inherit A1 allele from his grandparent, and one way he can get this A1 allele if the daughter of this male would inherit this A1 allele, and probability would be 1/2. And then once again this daughter can pass this A1 allele to her daughter, and probability would be 1/2. And then this daughter would pass this A1 allele to her progeny, and also probability would be 1/2. So from mother side, so this is going to be mother side and this is going to be father side. So from the mother side, probability to get A1 allele would be 1/2 multiplied by 1/2 multiplied by 1/2. And what is the probability that this child also would get A1 allele, but from the father side? And here is the pathway. This female also may get A1 allele from her father, and probability would be 1/2. So why 1/2 and not 1/4? Because both her parents has 4 alleles, as you see. But as you remember, 50% of the alleles of the genes contributed by father and 50% contributed by mother. And father can give whether A1 or A2 allele. So just two variants, whether A1 or A2. So probability for this daughter to inherit A1 would be 1/2. And also would be 50% probability that she also passes A1 allele to her son. And he also would have 1/2 probability, 50% probability to pass this A1 allele to his child. So the child would have genotype A1, A1. So once again, let's calculate this probability. So A1, A1 genotype, probability would be 1/2 multiplied by 1/2 multiplied by 1/2. This is probability that he would get A1 allele from the mother side. So this is mother, this is father. This is mother side, this is father side. And he also would have the same probability to get second allele from his father side. So probability to be A1, A1 would be 1/2 multiplied by itself 6 times. So 2 multiplied by 2, 4, 8, 16, 32, 64. So probability to be of this genotype would be 1/64, 1 out of 64. And also we can say that this child can be homozygous for A2 allele. And the same pathways would be to give the child a genotype that is going to be A2, A2. So A2 genotype also would equal to 1/2 raised 6, which equals to 1/64. And as for the A3 allele, this time we have slightly different pathway. This is going to be 1, 2, 3 first variant, and 1, 2, and 3 second variant. But nevertheless, as you see, to be homozygous for the A3 allele would be the same probability, which is 1 over 64. So A3, 1/2 in the power of 6, 1 over 64. And the same probability would be to be homozygous for the A4 and A4 allele would equal to 1/2 in the power of 6, which is 1/64. And to be homozygous for A5 A5 allele also would result in the same numbers, 1 over 64. So we have also allele 6. So probability to be homozygous for this allele would be 1 over 64, and probability to be homozygous for A7 allele also would be 1 over 64, and the last variant would be probability to be homozygous for A8 allele, and probability would be 1 over 64. So basically now what we have to do, we have to add all these probabilities. So for the to be homozygous for all these alleles. So we have to add 164 plus 164 plus 164 plus 164 plus 164 and plus 164 and plus 164. So how many? 1, 2, 3, 4, 5, 6, 7 plus 1 over 64, and we are going to get 8 over 64, or we can reduce by 8 and the answer would be 1/8. And this is going to be our answer. This is going to be inbreeding coefficient for this child, or probability for this child to be homozygous for any of these alleles. So inbreeding coefficient would be 1/8. But do not understand this, that probability for him to be homozygous would be equal 1/8. This is not probability for him to be inbreed. He would be inbreed. But what 1/8 means, so let me show you another example. Imagine that this is chromosome number 1, this is chromosome number 2. We have 23 pairs of chromosomes, and this time imagine that a child has on the chromosome number 1 about 2000 genes, and what this number that we got means 1/8. That means that 1 out of every 8 genes we expect to be, for this child to be homozygous. To be homozygous by descent for the same allele. So if we would have a allele here and a small allele here, this is going to be the same alleles inherited from the same ancestor, but these alleles came through, one through the mother side, another through the father side, and these alleles would be identical by descent. And here we may have another variant, say capital B, and also these alleles would be identical by descent. And in other 7 out of 8 chromosomes, we may expect that alleles would be different. So what does inbreeding coefficient means? And of course we would see the same picture on all chromosomes, on all 23 pairs of chromosomes. We can expect that 1 out of 8 chromosomic pairs of alleles, because this is going to be homologous chromosomes, one inherited from the mother side, another from the father side, from the mother side and from the father side, and 1 out of 8 allelic pairs we expect to be identical by descent. Now if you want to compare, we can compare who is going to be more inbred, child of the double cousins cross or child of the first cousins cross. This time I would go over example very fast. I will use formula in order to save time. So imagine this time we have situation where we have a family, so female and male here, and this family, say, has two daughters. These two daughters marry some man, and this daughter has also daughter, and this couple, another her sister, would have a male. So probably many of you has cousins, so this is how pedigree would look like. Now imagine that these first cousins want to marry and wondering about how inbred their child would be. So let's do the same analysis, and this time we would see picture like this if we would make line diagram. So this family has two daughters, and both parents contribute 50% of their genes to their daughters, and then we have another daughter here, son here, so this daughter is this person here, this son is this son. In this family we can add also another parent if you wish, but it is not important. You may not to add these people here, but for your convenience I can add them. And now we have to calculate probability for the child to be inbred. And this time we would have A1, A2 allele here, A3 and A4 allele here. So what is the probability for this child to be A1, A1? 1/2 here, 1/2 probability to get A1 allele here, and 1/2 probability here. Another 1/2, 1/2 and 1/2. So probability would be to be genotype A1, A1 would be 1/2 raised 6, which would equal to 1/64. And we can do the same calculations for each allele. So at the end we are going to get 1/64 plus 1/64 plus 1/64 and plus 1/64. And we are going to get 1/64, which equals to 1/16. And this is going to be inbreeding coefficient for the child that would result as mating of two cousins. As you remember, in our previous example we got number 1/8, and this time we got 1/16. So that gives us information that 1 out of 16 genes we expect to be homozygous by descent from the same ancestor. So that gives us information that double cousin mating would result in much higher inbreeding than a child of first cousins mating. And as I said, we can use also formula to calculate fast what the inbreeding would be. We just basically have to find how many rings we have here, and as you see we have one ring, and this is going to be another ring for the second parent. And when we have found how many rings we have, we can use formula. And here's a formula: 1/2 raised number of nodes. Let's find number of nodes in each ring. So in white ring we would have 1, 2, 3, 4 and 5 nodes. So 1/2 raised 5. And we also have another ring here, red ring. So once again 1, 2, 3, 4 and 5. So we have to add this probability also. So plus 1/2 raised 5. And as you see, we are going to get the same answer as 1/16. But this time it is much faster and easier, just took me a few seconds to solve. And when we use formula, just do not forget that we count all the nodes except child for whom we do these calculations of inbreeding. So we do not include this node. We only count all the nodes that lead to him, excluding him. So 1, 2, 3, 4, 5 in one ring, and 1, 2, 3, 4, 5 in other ring. I hope this information will helpful for you. Thank you for your attention. Please subscribe for my new videos that I post almost every day. Thumbs up if you like this video. Please share this video with your classmates, and see you in the next video. Goodbye.